Very good morning, all of you. Uh, Last class, we have discussed about the topic of bipolar junctions of a transistor. Okay, in transistor, there are three parts are very essential. You know very well, like as emitter, base, and collector. Okay, emitter is a main functions of charge carriers from the collector region. Once again repeat, emitter is a charge carrier, which means majority charge carrier from the collector region through the base region. So hence emitter is heavily doped than compared to the other two regions like as base and collector. Then after base is very thin region like 1 micrometer, which means 10 power minus 6 meter, and it is very lightly doped when compared to the other two regions like as emitter and collector, which means the main functions of collector, a majority charge carriers and supplied to the emitter through the way of base. This is the base of the transistor. Here we are going to see about the circuit configurations of transistor. So there are three types of connections operating a transistor based on the terminal that is used in a common both input and output circuit. So first of all, we see the configurations of common base, which means CB mode. So CB configurations or CB mode. So this is collector and this is emitter, and finally this one is the base. So base is the common both input and output circuits. The diagram will be provided and circuit symbol also provide here. The input current is the emitter current, which means IE. This is an input current. And the output current is collector current and IZ. The input signal is applied between of emitter and base. So measured by the collector and base. And second, and one more important topic also, a relation between alpha and beta. There is a relation between current gain and common base configurations of alpha, and current gain in the common emitter configurations is beta. So alpha equal to beta by 1 plus beta, or beta equal to alpha by 1 minus alpha. The relations between alpha and beta provided are for many 2 mark questions and also applications of some 1 mark questions. So this formula is very important to us, including board examinations. So keep in your mind. The next topic, transistor as a switch. So transistor acts as a switch. So this is an NPN transistor, which means we know that NPN transistor is emitter is in the directions of ground and collector in upward directions and base here. The transistor in the saturation and cutoff regions like on the electronic switch helps to turn on and not in on or off given the controlled signal. Though the circuit shows. So first of all we can see the presence of a DC source at the input saturation region. So first of all, when the high input voltage will be 5 voltage is applied to the base current. This is the input voltage is providing here plus 5 volt to applying directly through the RB in base current, so IB. So IB increases and it turn increases the collector current. Once again I repeat, and the input voltage will be passes through the base and IB value will be increases and also increasing the IC, so collector current. The transistor will move into the saturation region, which means turned on. the increase of collector current increases the voltage drop across or C. So collector current will be increases, this case will be increases the voltage drop across or C, thereby lowering the output voltage close to nearly equal to 0. So the transistor like as a closed switch, it is equivalent to the on condition. This is in a first case, presence of DC. In second case, absence of DC source at the input, which means cutoff region, which means here the input voltage we are providing a 0 volt, not in 5 volt, a 0 volt. So the base current turn decreases and also decreasing the collector current. Okay, so the transistor will be moved to the cutoff region, which means turned off. So the current drop across or C, thereby the increasing output voltage 5 volt. So the transistor acts open switch with the consider as a off conditions. So it is a manifest of that the high input gives low output and the low input gives high output. In addition, we can say the output voltage is opposite to the applied input. So we know that we are providing 5 volt, the output becomes 0. So we are providing a 0 volt, we get the output voltage becomes plus 5 volt. So it is a reciprocal compensation. So therefore the transistor can be used as a inverter. We know that inverter is nothing but a NOT gate. Okay, this is a logic circuitry. In second, operating point. So the operating point is a point where the transistor can be operated efficiently. A line is drawn with the values of VCC when IC becomes 0 and IC is called as DC load line. The DC load line superimposed on the output characteristics of a transistor is used to learn the operating point of a transistor. So the diagram will be providing here. Let's see the diagram very clearly. There are 3 points here, which means P, Q, R. Okay, the Q points. So the points of P, Q, R are called as points or quiescent points, which determine the operating point. So or the working point of a transistor. So beginningly in the stage of V, the base current becomes 0 milliampere and base current slowly rises. It gets the saturation region at particular current IB equal to 4 milliampere. This is a DC load line. So this is an operating point we get by using of changing of base current with the constant of collector current. And we are moving to the electronic topics, digital electronics. In digital electronics, which can be used the electronic device which the deals of addition, subtractions by helping of the signals. The ranging from the high-end processor circuit to miniature of circuits for signal processing. It is better performance like as accuracy, speed, and flexibility into noise. So in electronic digital electronics, we are using of there are two signals like as analog and digital signals. An analog signal is a continuously varying voltage or current with respect to time. Once again I repeat, an analog signal is a continuously varying voltage or current with respect to time. Such a signal have been employed in rectifying circuits and transistor amplifier circuits. And second one, digital signals. So digital signals are which contain only discrete values of voltage. So digital signals need two states like a switch on and off stage. So the on stage and also it can be defined as I. In low stage it can be defined as off. So on stage will be called as open, in off stage will be called as close. So this high low stage are defined using binary numbers like as 1 and 0 in Boolean algebra. 1 status high value and 0 status low value. Okay, there are two logic levels like as positive and negative. In digital system, there exists two voltage level like as 0 and 5 voltage. So 0 represent as 0 and 5 volt represent as 1, which means high voltage. So we are providing the value of 0, we get the value of 0 voltage, and we providing the on stage like as we get the value of 5 volt. This is positive and negative stages. Next topic. So the logic years will be reduced in our syllabus, so further we can move the topics of Boolean algebra. So in Boolean algebra in computer science students, you know very well about, because you have learned in 11th standard. So the same point of view will be providing in physics. So biology and pure science students, you must be know about what you mean by the formula and what tells us the algebra's formula following case of and or and not gates. Okay, so Boolean algebra is a basically choice between two options, which means is or no, or high or low state. We are providing the input value 0 is must be low value, in providing 1 in state that's high value. Okay, which means off stage, this one is on stage. So we can move the laws of Boolean algebra. So first of all, we can use this complement law. The complement law is nothing but we are providing two inputs, whereas a equal to 0 and 1. The output y becomes a complement. Complement means inverse value. We are providing 0. 0 complement is 1. We are providing the input 1. The 1 complement is 0. This is here complement law. In OR gate law, we know the formula of OR, which means addition. We are using of two value of OR gate inputs. So we are using 0 0 0 1 1 0 1 1. So 0 plus 0 becomes 0, 0 plus 1 becomes 1, 1 plus 0 becomes 1, and 1 plus 1 becomes 1. This is, so OR gate tells us if we provide any high or one of the high value, the output becomes high. If the two input will be low value, the output become must 0. This is our loss can be realized. So this tells us a plus 0 equal to 0, a plus 1 equal to 1, and a plus a equal to a bar equal to 1, because of we are providing 0. Then after 0 bar equal to 1. This is fourth law. And next important topic of De Morgan theorem. So De Morgan theorem is the most important questions. It also like us 2 and 3 more questions. Some based on De Morgan theorems, 1 mark questions also provide by using of circuits. So clearly understand what I am telling. So first process, whereas here a plus b whole bar equal to a bar dot b bar. This is the first theorem. The first theorem states that the complement of the sum, this line will be tells us complement. The complement of the sum of two logical inputs is equal to the product of its complements. So listen students, here we are adding of the two inputs in the complements, which is equivalent to the product of the complements, additions, and the results will be product of the complement. This is first law. So we are prove by using a truth table the two inputs like as we know that 0 0 0 1 1 0 1 1, and adding the value of 0 if any one logic level will be high, the output becomes high value. So remaining the three cases must be having the value of I. So we are taking as the complement of a plus b here. So 0 becomes 1 and 1 becomes 0. In second cases, we are taking as the complement of e and b respectively. So 0 becomes 1 and 1 becomes 0, the reciprocal value. So multiplying the complements of e and b, we get the value of. So here, say this table, the a plus b whole bar, which is equivalent to a bar and b bar. This is the De Morgan's theorem. So first theorem will be proved. And then second one, De Morgan's second theorem. So second theorem we can write as a b whole bar equal to a bar plus b bar. So the theorem tells us, the second theorem tells us the complement of the product of two input. Once again I repeat, the complement of the product of the two input, which is equivalent to the sum of the, which means sum of its complements. This is De Morgan second theorem. So the same way we can prove by using a truth table. So AB, the same way, product, if any logical level will be becomes 0, the product must be 0, we know that. So the last one, the two logic will be high, the output becomes high. Taking the complement, 0 becomes 1 and 1 becomes 0, and taking the complement of e and b respectively, we get the value of a bar and b bar. So adding these two complements, a bar and b bar, we get the value of here. So in this table we can clearly understand a dot b whole bar, which is equivalent to a bar plus b bar. So hence the second law will be proved. The second law tells us, we know that the complement of the product a dot b whole bar, which is equivalent to the sum of the its complements. This is De Morgan's second theorem. Okay. In the next one, integrated chips, which means IC. So it consists of thousands to millions of transistor, resistor, capacitor, etc. So integrated on a small flat of piece of semiconductor material is that is normally. So normally silicon appliances are now made possible by the small size and low cost of ICs. We know that IC can function as a amplifier, accelerator, timer in microprocessors in computer memory. There are extremely small ICs can be perform calculations and store data by using of either digital or analog technology. So digital ICs of logic gates, which works only the values of ones and zeros. We know that the low signal sent in to be a component on the digital IC will be result in the value of 0, which high value signal creates the value of 1. So digital ICs usually find the applications in computers, networking equipment, and most consumer electronics. Analog ICs or linear work in continuous values. This is an integrated circuit. So we have completed the which means 10th lesson of part of the 10th lesson. Remaining the communication system, we can further move in afternoon session. So children, study the formula of De Morgan's theorem with comparing with the truth table, and find out whether the law will be proved or not. Okay, if you have any doubt to clear, contact me. Thank you.